Hi class, welcome to our lesson in Chemistry 2. This is our lesson in 6.5. We're basically just gonna do the practice problems and solutions that I've already uploaded in your LMS. So let's begin by doing sample problem 1. So sample problem 1 is basically percent mass, which if you guys remember, percent mass concentration is basically the ratio of the mass of solute and the mass of your solution. So let's read our problem. If you want to make 3,000 grams of 5% solution of sodium chloride, which is NaCl, how much solute should you add into your solution? Okay, so let's begin by writing our given. So our first given is they gave us the grams of our solute. So if you want to make 3,000 of 5% solution. So this 3,000 right here is actually the mass of our solution. So the mass of solution is equals to 3,000 grams. And what is it saying here is that 3,000 grams of 5% solution, this 5% right here is already our concentration. This is our percent mass. So the percent mass concentration is equals to 5,000 or 5%. And the solute that we have in this solution is sodium chloride. And what they're asking is how much sodium chloride do we have, the mass of sodium chloride. Then if let's go ahead and remember the formula. If you guys remember, the formula for mass percent is basically mass percent is equals to the mass of solute, which in this case our solute is our NaCl, divided by the mass of our solution multiplied by 100%. Okay, so in this scenario they're asking for the mass of NaCl, the mass of solute. So we have to rearrange this formula to get the mass of solute. To do that, what we have to do is basically rearrange this and we'll get this equation right here. So let's just write solution. The mass of solute is basically equals to, we have to multiply both sides by the mass of solution. So we have percent mass multiplied by the mass of the solution. And then we have to divide both sides by 100%. So that is divided by 100%. Okay, so now that we have our equation rearranged, let's plug in our numbers. Mass of solute is equals to percent mass, which is 5%, multiplied by the mass of solution, which is 3,000 grams, and divided by 100. And that would actually give us the mass of our solute is 150.0 grams of NaCl. And in real life problem, this is how you actually use percent mass. Usually your professor or your research professor would tell you to make him this amount of how many percent of solution. And what you usually need to do is to identify how much solute you have to add on your solvent to make that solution. In this case, if you want to make 3,000 grams of our solution and we want a 5% solution, we have to add 150 grams of, in this case, the solvent that we have is water. If you guys remember, the mass of solution is mass of solute plus mass of solvent. So for 3,000 grams, what we need is 2,750 grams of solvent, which in this case would be H2O. Okay, so this is the mass of our solvent. Okay, So that is percent mass. Now let's head to our second problem, percent volume. If you guys remember, percent volume is basically the ratio of the solute divided by the volume, or the ratio between the volume of our solute divided by the volume of our solution multiplied times 100%, because we're looking for percent concentration. So let's read the equation. How many ml of HNO3 concentrate are needed to prepare 250 ml of 4% solution? So it's very similar on the previous example. What they're asking us is how much solute we need. So let's write our given first. We are given that the volume of our solution is actually 250 ml. And in this case, we are given the percent volume of our solution, which is 4%. And what they're asking us is how much volume of solute do we need to create this solution. If you guys remember the formula, 4% volume, it's basically percent volume is equal to the volume of solute divided by the volume of solution. Again, we just have to rearrange this equation to get the volume of solute, which in this case, the volume of solute is equals to percent, oh, forgot the 100% right here. It's equals to percent volume multiplied both sides by the volume of the solution, and then we have to divide both sides by 100%. Okay, so let's just plug in the number. The percent volume is 4% multiplied by the volume of our solution, which is 250 ml, divided by 100%. And that would actually give us 10 ml of HNO3. Okay, so that is our equation. And again, this is very similar in how you would do it in real life setting. Usually, your professor would ask you to prepare a certain amount of solution and a certain percent of solution. And what you're usually looking at is how much volume of solute you need to have, and then you just have to create that 250 ml solution. So that is percent volume. Okay, next let's go and head to the next part, which is the combination of both, which is percent mass per volume, or mass volume. Okay, let's read the problem. 10 grams of BaCl is dissolved in 90 grams of H2O. Calculate the mass volume ratio concentration of the solution. The density of the solution is 1.09 grams per milliliters. Let's write our given. In this scenario, we are given 10 grams of BaCl2, and we are given 90 grams of H2O. In this scenario, understand what these are. This H2O is basically our solvent, while this BaCl is actually our solute. And what they're asking us, or they also gave us the density of our solution. So density of solution is equals to 1.09 grams per milliliter. And what they're asking us is the percent mass volume concentration of this solution. Let's remind ourselves what is the formula for percent mass volume. Percent mass volume is equals to the mass of your solute divided by the volume of your solution. Remember, we are talking about solution, not solvent. Okay, so how are we going to solve this? As you can see from the equation, what we need is the volume of solution, but what we have is the grams of our solvent. If you guys remember first that the mass of solution is equals to the mass of solute plus the mass of your solvent. So in order to get the mass of our solution, we can add these two numbers. 10 grams of BaCl to plus the mass of your solvent, which is H2O, which is 90 grams of your solvent, which is H2O, and the mass of your solution is basically 100 grams. But again, what we need is volume, not mass. This is mass. What we can do now is use the density of the solution to solve for the volume. So what we need to do is multiply, basically multiply the density to the mass of solution. So the mass of solution is 100 grams, and we have to multiply. We have to put the grams below because we are canceling grams, and what we need is milliliters, and this would actually give us 91.74 milliliters of solution. Now that we have the volume of our solution. Now we can solve for the percent mass volume. So the mass of our solute is 10 grams BaCl2 divided by the volume of our solution, which is 1.74 ml. And that would give us, again, forgot times 100%. Do not forget the 100% because this is percent mass. And this would actually give us 10.90% concentration. Okay, so I want you guys to remember this example 3 because this would actually show up on your monthly test. A very similar example would show up on your second monthly test. Okay, now let's move to mole fraction. Okay, so if you guys remember, for mole fraction, what we have to do, mole fraction of a single substance is equals to the mole of that substance divided by the total moles of all substances present in the solution. Let's begin by reading the problem. A solution contains 10 grams pentane, which is C5H12. We also have 10 grams of hexane, C6H14, and 10 grams of benzene, which is C6H6. What is the mole fraction of each substances? So let's begin by writing our given. So we have 10 grams of pentane, which is C5H12. We also have 10 grams of hexane, which is C6H14. And we have 10 grams of benzene, which is C6H6. Okay? Now, what are they asking us? what they're asking us is actually the mole fraction. Again, the mole fraction is basically the ratio between the mole of a single substance divided by the total moles of all the substances present in the solution. So what they're asking us is we use the letter G. This is actually G, not just X. G, and for pentane, G for hexane, and the mole fraction for benzene. So let's remember the formula for mole fraction. Because remember, for a certain amount, for mole fraction of a certain formula, what you need is the moles. Let's use N to denote moles. The moles of that substance present in the solution, A, divided by the moles of A plus the moles of B, etc. What this means is you have to add all the moles of all the substances present in your solution. And no matter how many is that, so if you have 3, in this case you have 3, that would be Na plus Nb plus Nc. Let's also remember to solve for moles. Moles is equals to, because we need moles, this is moles, this letter N here is moles. Moles is equal to the mass of the substance divided by the molecular mass. So in this scenario, we have to find the molecular mass of each substances. Okay? So you can use the internet to find the moles of each substances, or to find the molecular mass of each substances, or you can actually compute them on your own by finding the molecular or the atomic weight of each of these elements and then multiply however how many elements that is. So for example, we have 5 C's for pentane. So whatever the atomic weight of C multiplied by 5, and that add that to the atomic weight of hydrogen multiplied by 12. So in this case, let's just write the molecular mass of each substances. The molecular mass for pentane is actually equals to 72.15 grams per mole. For hexane, the molecular mass for hexane is actually equal to 88.16 or 0.18 grams per mole. While for benzene, the molecular weight of benzene is equals to 78.11 grams per mole. Okay, now that we know the molecular mass of each substances, let's first solve for moles solution. Let's first find the moles of each substance. So the moles of pentane is equals to the mass of pentane, which is 10 grams, divided by 72.15 grams per mole. And that is actually equals to 0.1386 moles. Okay, then the moles of hexane is equals to 10 grams divided by the molecular mass, which is 88.18 grams per mole, and that is equals to 0.1160 moles. You can use this to solve for the moles of benzene, but another formula that I want you guys to remember is also the mole fraction for each of these XA plus GB plus C, etc. would also equal to 1. Okay, moles of benzene. Moles of benzene, again, that's 10 grams divided by 78.11 grams per mole. And that is equals to 0.1280 moles. Now that we know the moles of each substances, what we have to do next is to add all sum of all moles. So that's 0.1386 plus 0.1160 plus 0.1280 is actually equals to 0.3826 moles. So now that we have the sum of all substances, we can find the mole fraction. So this is N, this is G. So the mole fraction of A is equals to the moles of A, which is 0.1386, divided by the sum of all the moles, which is 0.3826. And that is actually equals to, instead of A, this is pentane. So this is pentane, and this is equals to 0.3623. So that is your first mole fraction for pentane. Now let's solve for the mole fraction of hexane. The mole fraction of hexane, take the moles of hexane, which is 0.1160 moles, divided by the total moles, which is 0.3826, and that is actually equals to 0.32 or 3032. You can use this equation to solve for the mole fraction of benzene, or you can actually use this already, because X or G mole fraction of pentane plus mole fraction of hexane plus mole fraction of benzene should actually equal to 1. Therefore, the mole fraction of benzene is equals to 1 minus the mole fraction of pentane minus the mole fraction of hexane. And that is equals to 1 minus 0.3623 minus 0.3032. Therefore, the mole fraction of benzene is actually equals to 0.3345. Again, you can use this, or you can use that formula to solve for the mole fraction of benzene. Okay, so that's how you solve for the mole fraction. Okay, next let's go and solve molality. If you guys remember, molality is basically the ratio of the moles of your solute divided by the kilogram of your solvent. So let's read the sample problem. A sulfuric acid solution containing 571.4 grams of H2SO4 sulfuric acid per liter of solution has a density of 1.329 grams per cubic meter. Calculate the molality of H2SO4 in this solution. So let's write our given. So the sulfuric acid solution has a mass of of H2SO4, which is 571.4 grams per liter of solution. Okay, so this the density of your solution is equals to 1.329 grams per cubic centimeter. Calculate the molality. So what is being asked is the small letter m. Small letter m stands for the molality of the solution. So the concentration of H2SO4 in this solution. Sorry. So let's write our formula. Let's remind ourselves what is the formula. Molality is equals to the moles of solute divided by the mass in terms of kilogram of our solvent. Okay, so let's head to the solution. So how are we going to solve this? Well, they gave us the mass of our solute, which is 571.4 grams, but what we don't have is the kilogram of our solvent. So what we need to do first is find the mass of our solvent. Okay, so how are we going to do that? First, let's try to find the mass of our solvent, and we can do that. If you guys remember, mass of solution is equals to the mass of solute plus the mass of our solvent. What we need is the mass of our solvent. And in this problem, a sulfuric acid solution containing this amount per liter of solution. So we can take 1 liter of our solution, which is actually equal to which is actually equal to 1000 milliliters. 1000 milliliters. And what I want you guys to remember, 1 milliliter is equals to cubic centimeter. So we can actually find the mass of our solution. So we have the mass of our solute, we don't have the mass of our solution, and we are looking for the mass of solvent. So we have to find the mass of our solution first. So to get the mass of solution, we have to take this 1 liter of solution and use the density to find the mass of our solution, which is equals to so we have 1 milliliter. So in this case we have 1000 cubic centimeter. Okay, let's just use 1 liter for now so we don't get confused. So we have 1 liter multiplied by the density, which is equals to 1.329 grams per 1 cubic centimeter. And as you can see, guys, cubic centimeter is equals to 1 milliliter. So 1 cubic centimeter is equals to 1 milliliter, and 1 milliliter is equals to 1000, or 1 liter is equals to 1000 milliliter. So we can cancel the milliliter, we can cancel the cubic meter, and we can cancel the liters. So what I basically have is multiply 1.329 grams to 1000, and that would give us 1329 grams. So this is the mass of our solution. Now we can solve for the mass of our solvent. Mass of solvent is equals to the mass of solution minus the mass of solute. And we have 1329 grams of solution minus 571.4 grams of our solvent. And the mass of our solvent is actually equals to 757.6 grams. But we're not done yet. This is just the mass of the solvent. What we need is to solve for the molality. So we have now the mass of our solvent. What we need is the moles of our solute. So we have to search for the moles of solute. Moles of solute, remember, is the grams of your substance divided by its molecular mass. So we have the mass of our solute, which is 571.4 grams. What we need is the molecular mass of H2SO4. And the molecular mass of H2SO4 is actually 98.079, or let's just say 0.8 grams per mole. And again, you can search this using the internet or find the molecular weight of each of these elements and then add them all up, multiply the molecular weight of H by 2 and the molecular weight of oxygen by 4, and then add them all up. So that's 98.08 grams per mole. So the moles of our solute is equals to 5.826 moles. Now we can search, we have the grams and we have the moles. We can search for, we can solve for the molality of this solution. So we have 5.826 moles divided by 757.6 grams is actually equals to 0.75076. What we need, again, remember, we need kilogram, not grams. So that is equal to 7.690 molal. So that is the molality concentration of this solution. Okay. Okay. Now for our next problem, we will tackle molarity problem. If you guys remember, molarity is basically the ratio of the moles of your solute per liter of your solution. In this problem, what we have is a solution of H2SO4 with a molar concentration of 8.10 0.10 molal has a density of 1.354 grams per milliliter. What is the molar concentration of this solution? Okay, let's begin by writing our given. So what is our given in this scenario? First, we are given the molar concentration of the solution, which is 8.010 molal. If you guys remember, molar concentration is equals to moles per kilogram of solvent. And we're also given the density of our solution, which is 1.354 grams per milliliter. And what they're asking us is the capital M, which is molarity. Let's remind ourselves what is the formula for molarity. Molarity is equals to the moles of solute divided by liters of solution. Okay, so in order to solve this, we first have to find the moles of our solute and the liters of our solution. But in this case, neither were given. So how can we find the moles of our solute? To find the moles of our solute, we know that we have to have the grams of our solute. So as per solution, what we have to do first is to find the mass of our solute. And how can we do that? Well, they gave us the molal concentration. So the molal concentration uh, this uh, of this solution is 8.10 moles per kilogram. Correct? This is kilogram of solvent. Remember that? This is for solvent. Let's remind ourselves what is the molecular mass. The molecular mass of H2SO4 is equals to 98.08 grams per mole. As you can see here, the unit for molar mass is grams per mole. So we can actually multiply the mole mass of the solute multiplied 98.08 grams divided by moles. We can cancel the moles and we can actually get the mass of our solute per kilogram of our solvent. So the mass of solute 8.010 multiplied by 98.08 is equals to 785.6 grams of solute per kilogram. We still have the kilogram per kilogram of our solvent. So now that we have the grams of our solute, we can actually solve for the moles of solute. But before we do that, the next thing that we need is uh, this one right here, which is the liters of our solution. But as you can see, we do not have the liters of our solution. But what we have is the molar concentration. We have the kilogram of our solvent and the mass of our solute. Mass of our solvent, mass of our solute is equals to the mass of solution. So we have to add these two. What we need to do then is 1 kilogram is equals to 1000 grams of our solvent. So the mass of solution is equals to the mass of solute plus mass of solvent. So the mass of solute is 785.6 grams plus kilogram of solvent is equals to 1000 grams. That would give us 1785.6 grams of solution. Now that we have the mass of solution, we can use the density of solution to find the milliliters of our solution. So that is 1785.6 grams times the grams of our solution, which is 1 point, or the density 459 for 1.354 grams per 1 milliliter. Cancel the grams and we'll get the mass of our the volume of our solution is actually equal to 0.13188. So that's quite a lot, 13,000 ml. But since we need liters, let's go ahead and divide that by 1,000. So 1000 ml is equals to 1 liters. Cancel that and we get 1 point. It's actually point, not 13,000. This is 1,318. So that's 1.3188 liters. So now we have the liters of our solution. Now that we have the liters of our solution and we have the moles of our solute, the moles of our solute is right here, 8.01. We can solve for the molarity. The molarity is equals to 0.810 moles. But now, instead of per kilogram of solution, we need liter or kilogram of solvent. We need the liters of solution, which is 1.3188 liters. And the molarity is equals to 6.074 molal or molar. So that is the molarity of the solution with a 8.010 molal concentration. Okay, so that is the molarity. Next, let's head the stoichiometry. Guys, remember stoichiometry reaction, we want to usually use this to find the relationship between the mass or between the product and the reactants. So in this case, we have a silver, which is often extracted from ores from this equation right here, K, potassium, silver, cyanide, not cyanide, this is Cn2, and then recovered by the reaction. So in this reaction, I've already balanced this equation right here. So what they're asking is how many molecules of Zn2. So this is Zn2 are produced by the reaction of 35.27 grams of KAgCN2. So we have a relationship between product and reactant. Next is what mass is produced. So they're asking for not only how many molecules but the mass of our product. Okay, so if you guys remember for step 1, take the given mass and change it to moles. In this case, the given mass is 35.27. Okay, this is our given. This is 35.27 grams of our reactant. So to change it to moles, we have to find its molecular mass. And again, you can use the internet or you can solve for the molecular mass of this reactant. But the molecular mass of this reactant is actually equal to 199 grams per mole. So the mole is equals to 35.27 grams multiplied by 199 grams per mole. And the mole of our reactant, KAgCN2, is equals to 0.1772 moles. And for the second part, you guys remember, use the mole ratio. In this case, we need the product and the reactant mole ratio. We know that 2 moles of K silver Cn2 is equal to 1 mole of zinc Cn2. So using this mole and this mole ratio, we can solve for however how many moles to solve for the moles desired substance. Okay, so we have 0.1772 moles of KAgCN2 divided by or multiplied by 2 moles per 1 mole. This is zinc CN2. And we'll actually get the moles of ClCN2 is 0.0886 moles. And for step 3, we can change this mole to what is being asked. In this case, we are looking for molecules. When we look for molecules, we can use the Avogadro's number. Any mole you multiply to Avogadro's number is actually equal to the molecule of that substance. So by multiplying 0.0886 moles multiplied by Avogadro's number is actually equal to 6.02 to etc. times 10 raised to 23. You'll get 5.34 times 10 raised to 22. So molecules. This is not moles now, this is molecules. This is just an extra step because it's asking for molecules, not grams. This is extra step. If you want to know how many molecules of ZnCN2 you have. Another part of step 3, mole to the ask. In this case, this is for letter A. What we're looking for is letter B. What is the mass? Now we can use this mole and the molecular mass of Zn. The molecular mass of ZnCN2 is actually equals to 117.4 grams per mole. You can use this molecular mass and the mole that you got on step 2 to find the grams. So 0.0886 moles multiplied by 117.4 grams per 1 mole of zinc CN2. You cancel the moles and you get that the grams of zinc CN2 you have is 10.40 grams. So this is for step B. Usually we go from 1 to and here, but this is just an extra step because we're looking for the molecules. For the test, you usually just go straight in the here. You don't have to do the extra step for monthly test. You just have to do this step 1, 2, and 3 for stoichiometry. Next, let's go straight to our last topic, which is the colligative properties of solution. If you guys remember the colligative properties are properties of a solution, most of the time liquid, specifically vapor pressure, freezing point, boiling point, and osmotic pressure. They changes depending on how much or the number of your solutes in your solution. So in this case, let's have this sample problem and try to solve for the two things that we have focused, the boiling point and the freezing point for the colligative properties. So ethylene glycol, C2H6O22, is a molecular compound that is used in many commercial antifreeze. An aqueous solution of ethyl glycol is used in vehicle radiators to prevent the water in the radiator from freezing by lowering its freezing point. Calculate the freezing of a solution of 40 grams of ethylene glycol in 500 grams of water. Okay. Let's begin by writing our given. So what is our given? So the first thing that they gave us is we're looking for the calculate the freezing of a solution of 400 grams. They gave us 400 grams of ethylene glycol. So that's C2H6O2, and they gave us 500 grams of H2O. Moreover, they actually also gave us the molar mass of ethylene glycol. They gave us the Kf of our solvent and the Kb of our solvent. Okay. Now let's try and solve for um, they're only telling us to calculate the freezing of our solution. Also, let's look for boiling as well. I'm not gonna write these given anymore because it's already written here. So let's just do asked. The ask is the freezing and the boiling point of the solution. Let's remind ourselves of the formula for freezing. So delta Tf is equals to negative temperature of your solution minus the temperature of your pure solvent is equals to Kfm, and for delta Tb is equals to T solution minus temperature of your pure solvent is equals to Kbm. Solution. Let's begin with the freezing. In order to get the difference on the freezing, we first have to find the molality of our solution. If you guys remember, molality is equals to the moles of solute divided by the kilogram of our solvent. So first, let's identify the moles of our solute. To identify the moles of our solute, we can get the mass of our solute, which is 400 grams, divided by the molar mass, which is 62.08. And the moles of our solute is 6.44 moles. Now let's solve for the molality. The molality is basically 6.44 divided by 500 grams of our solvent. 500 grams, we just need to change that to kilogram. That is actually 0.5 kilogram. And that is equals to 12.9 molal. Now that we know the molal, we can use the Kf of the solvent to solve for delta Tf. So Kf multiplied by the molar concentration. And the Kf of H2O is 1.86 degrees Celsius per molal, and that's 12.9 molal. Cancel the molal, and the change in the temperature is actually equal to 24.0 degree Celsius. Now let's find the temperature of our solution. From this equation here, the temperature of our solution is actually equals to the temperature of our pure solvent minus delta Tf. And we know that the temperature of a pure solvent, the freezing temperature of pure solvent, in this case we have water. The freezing temperature of water is 0 degrees Celsius minus, in this case you have 24 degrees Celsius. So the freezing point of our solution is actually negative 24.0 degree Celsius. So that is the freezing. Now let's look for the boiling. So freezing and boiling. For boiling, we have delta Tb is equals to Kb multiplied by m. We already solved for the molar concentration of our solution. We just have to plug in the numbers. The Kb of our solvent is 0.52 degrees Celsius per molal multiplied by 12.9 molal. Cancel the molal, and we get that the change in temperature is actually equals to 6.71 degrees Celsius. And for the temperature of the solution is equals to the temperature of pure solvent. In this case, we have to add, because this is boiling, delta Tb. So the boiling point of our pure solvent, the boiling point of water is 100 degrees Celsius plus 6.71 degrees Celsius. And what we get is 6.71 degrees Celsius. That is the boiling point of our solution. So that is how we solve for the boiling and the freezing point of our solution when we added a certain amount of solute. So our solute here is ethylene glycol. We added ethylene glycol to water, and it changes the temperature and for boiling point and the freezing point of water. So instead of freezing at 0 degrees Celsius, it freezes at negative 24.06 or zero point 0 degrees Celsius. And instead of boiling from 100 degrees Celsius, now it boils at 106.71 degrees Celsius. So that's for colligative properties. Now let's head to the last problem, which is the colligative properties of solution. This time we have to find the molar mass of a solute. Remember again, this is for solute. To make a solution, 38.7 grams of non-electrolyte is dissolved into 218 grams of water. The freezing point of the solution is measured to be negative 5.53 degrees Celsius. Calculate the molar mass of the solute. So let's write our given. So we were given 38.7 grams of our solute dissolved in 218 grams of water, which is our solvent. And the freezing point of the solution is measured to be 5.53 degrees Celsius. Let's head for asked. So calculate the molar mass of our solute. And if you guys remember the formula, the formula is basically change in temperature is equals to delta Tf is equals to Kf m. Okay, and for molar mass is equals to grams per moles. Okay, so let's write the solution. For here, first we have to find the molality of the solution. If you guys remember the molality of our solution, we usually have to solve for the moles of solute divided by the kilogram of our solvent. But in this scenario, what we can do is use this equation right here. We're not going to use this to find for molality. And this is find molality. We cannot use this because we don't know the moles of our solute, but we know the grams of our solute. So what we can do is use this equation, delta Tf is equals to Kf m. So m is equals to delta Tf divided by Kf. Because remember, delta Tf is equals to negative solution temperature of the solution minus temperature of pure solvent divided by Kf. And the temperature of the solution is given, and our solvent is water. And we know that the freezing temperature of water is 0 degrees Celsius, so we can plug in the numbers. That's negative 5.53 degrees Celsius minus the freezing temperature of our solvent, which is water, is 0 degrees Celsius divided by our Kf. The Kf of our water is 1.86 degrees Celsius per mole. And the molar concentration of our solution is actually equals to 2.97 mole. So after getting the mole, what we can do now is to find the moles of solute. And we can do that by using the molality. Remember that molarity is equals to the moles per kilogram of our solution. And we know the mass of our solvent. This is solvent, sorry, not solution. Kilograms of our solvent. And we know the mass of our solvent. So by multiplying the mass of our solvent, 2.18 is basically equal to 2.18 grams divided by 1000. Well, let's do this instead so it's clear. Multiplied by 218 grams, and we know that 1000 grams or 1 kilogram is equals to 1000 grams. We can cancel the grams, we can cancel the kilogram, and we'll be able to get the moles. And the moles of our solution is actually equals to the moles of our solute is 0.648 moles. And now that we find the moles, we can find molar mass. And molar mass is equals to the grams of our solute, which is 38.7 divided by 0.64. And our molar mass is equals to 59. This is actually 648. Let's add that. That's 6. That's 559.7 grams per mole. So that is the molar mass of our solute. Again, you didn't have to know what solute you have. You just need one information from its colligative properties, and then you can deduce the molar mass of your solute. So that is our last problem for lesson 6. I think it's lesson 6. So if you guys have any question with these problems, do not hesitate to message me and contact me so I can clear any question or things that is not clear. And thank you so much, guys, and have a great day.